right, so 2-3 is titled exponential functions, okay? And the focus is on mostly like what the parent function of a graph looks like and what the behavior of it becomes, okay? So we're going to talk about things like increasing and decreasing, concave up, concave down comes back in this section, things like that. So, and we start with just an exponential function. So this slide, and we're going to pay attention to how it gives you your function notation. This slide says the exponential function f with base a is denoted by f of x equals a to the x, where a is greater than 0 and not equal to 1. So in this example, I only have that one term, f of x equals a to the x, okay? Where a is the base, and I know it's the base because it has an exponent. Sometimes you'll see it like this. Sometimes you'll see it as a b to the x. And in that format, now what's the base? B, okay? So when like anytime you've got like an FRQ that asks you to give it a function, it's going to say this sort of data gives you, would result in a function that is f of x equals, and it will give you the actual example of what it should be, okay? So in either of these cases, the base would be greater than 0, meaning the base itself would be positive. If there's a negative on the front, that is the reflection of the graph and not the actual base itself, okay? So if I said negative 3 to the x, what do you raise to the power? The 3, and then you take the negative, right? That's different from this. Does that make sense? So the base itself would be a positive 3. The negative on the front is going to have an effect on the graph. It's going to flip it upside down or reflect it over the x-axis. But the base itself is a positive 3. And the base can't be 1 because no matter what you raise 1 to, what is it? 1. And then that would result in a constant function, not exponential. Okay? So exponential functions have both growth or decay. If it's got growth, then it is increasing as I move from left to right. And if it has decay, it is decreasing as I move from left to right. So a lot of real world examples in exponential growth and decay. Things like population have exponential growth or decay. They could also have decay. Bacteria could do, like grow at a rate of blah, 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 exponential, okay? Some things like elements could have a half-life or that kind of thing where it would have decay. So there's a lot of real world stuff here. For exponential growth, so on the left, my A is greater than 0, and my B is greater than 1. So your B could be 2, it could be 1.1 even, but it has to be bigger than 1. And we're saying the A, which would be on the front, is positive. If my A were negative, what happens? It flips it over the x-axis, and it would then change to decay because it's falling. All right, then comes exponential decay. And in this case, my A is still positive, but my B is in between 0 and 1. So this could be f of x equals 2 times 1/2 to the x. This could have been f of x equals, 2 to the x, or 2 times 2 to the x, or 3 times, whatever it is. Doesn't matter, as long as the base is in between 0 and 1. So in between 0 and 1, decay. Could be fraction, could be decimal. Greater than 1, growth. If there's a negative on the front of the 1/2, what does that cause? Flips it over the x-axis. Oops, not that way, sorry. And that one's actually going to have growth. With me so far? Mm-hmm.
The right one that you drew on the left, is that decay?
Yep. Okay, so determine if the function is growth or decay and justify your answer. So notice all the A's are positive, right? If they're positive, then I'm just focusing on what my base is. Is my base greater than 1 or in between 0 or 1? So what's happening with A?
It's less than 1.
It's in between 0 or 1, which would make this decay. And if it says Y, it's because A is greater than 0 and 0 is less than B, which is less than 1. Go to B. What's true about my base? Bigger than 1. So exponential growth or decay? Growth. Because A is greater than 0 and b is greater than 1. Good. And the last one, what's true about b? Greater than 1. It's a fraction, but it's an improper fraction, so it's bigger than 1. So that's growth or decay? Growth. Growth. Because a is greater than 0 and b is in between 0 and 1. Nope, just kidding. B is greater than 1. Easy stuff, yes? Okay. So now, look at how it could take something and manipulate it. Obviously, make it this crazy word problem that's actually quite basic if you understand what you're looking for. It says, the following values are output values of an exponential function of the form f of x equals a times b to the x, where a and b are constants. Write the function along with the input value that represents the output value. So these are your output values, okay? It wants you to use those to set up a function, and then it wants you to say what would have been the input value on that function to result in this output value. So notice there's something that repeats and there's something that doesn't repeat, right? What would repeat, the A or the B? The B, right? The B is the one that's going to be raised to a power, which means it's going to repeat. So in A, your B is 3. And your A is 2.5. 2.5 would be the initial value. 3 would be the base. So 2.5 times 3, and 3 could be to the x inside the parentheses, or the x could be outside the parentheses, as long as 2.5 is not inside the parentheses. Now, what specific input value would have resulted in this specific output?
3.
Good. There are 3 3s. So my input was 3. Make sense? Okay, so go to B. What's your A? A is 3.5, and the B? 0.03, or 0.3. So 3.5 times 0.3 to the x. And what's the x? Again, 3. Yep.
Will there ever be a time when there's one of the numbers repeats twice and one of the numbers repeats
No.
3 times?
No. Questions? Okay. Now let's talk about the characteristics of the graph and the end behaviors of the graph, okay? Your exponential functions are either always increasing or always decreasing. And there's no max or min because my arrows are always going down or my arrows are always going up. So, or no absolute max or absolute min, okay? So if I was to look at a graph that had growth, okay, what's true about those values? They're always increasing or decreasing? Increasing. And if I had decay, they are always decreasing. If I flip these over, it changes, right? If I have a negative on it, so it reflects it, now that purple graph reflected would look like this, and now it's always decreasing. And the orange graph would look like this, so now it's increasing. The second point says graphs are always concave up or always concave down. So these would always be on the U, which would mean what? Concave up, good. And the examples I had drawn before would always be on the ends, which would be? Concave down. And so that means there's no inflection point, right? Because it can't change from concave up or concave down. It is always one or the other. And then the last thing says, if the input values increase or decrease without bound, then the end behavior can be expressed as, there are only 3 options here. Well, kind of. One is that it goes to positive infinity. One is that it goes to negative infinity. The last is that it goes towards the horizontal asymptote. So if I had an exponential function that looked like this, where is your horizontal asymptote? At 0. What would cause a horizontal asymptote to shift? What kind of transformation on a graph? Shift right, left, shift up, down, stretch, shrink. Which one? Up, down. What causes a shift up, down? The vertical shift would look like what in an equation? Plus or minus something outside the exponent, right? So it would be something like f of x equals 3 to the x plus 2, for example. So if I'm adding or subtracting, which these get reviewed in tomorrow's section, but if I'm adding or subtracting outside the exponent, that causes a vertical shift, and a vertical shift is going to move your horizontal asymptote. And then my exponential function goes with it. Yeah, sure. So if I'm going off that first example, this one here, the orange graph, what the limit as x goes to negative infinity would be what? 0. And the limit as x goes to positive infinity would be what? Infinity. So one side's going to go positive or negative infinity. The other side's going horizontal asymptote. Now go to the one that we shifted up. The limit as it goes to negative infinity would be what? 2. Good. And the limit as it goes to positive infinity? Positive infinity. So one of them is always going to be unbounded. Positive or negative infinity. And then the other one's always going towards your vertical asymptote. Horizontal asymptote. Horizontal asymptote. Still with me?
Yes.
Okay. All right, so now we're going to get an equation, and we're going to answer questions based on that equation. I would strongly recommend you draw it out, okay, so that you can look at it and understand what you're looking at. Obviously, you could try to figure it out, but also a visual always helps. So if it is 2 times 3 to the x, does it have growth or decay? Growth, and it's above the x-axis, right? Is this function always increasing or decreasing? Increasing. Is this always concave up or concave down? Concave up. What's my end behavior? It goes to negative infinity, 0. And as it goes to positive infinity, positive infinity. Yep.
Will it always have a horizontal asymptote?
Yeah, exponential functions always do. All right, example 2. Now it says negative 2, 3 to the x. What's that negative 2 going to do? Well, what's the negative doing? Goes upside down. So normally it looks like this, but now I'm flipping it upside down. So it's going over the x-axis. Oops, too much. Is this always increasing or decreasing? Decreasing. Is it always concave up or concave down? Down. The limit as x goes to negative infinity? 0. And as it goes to positive infinity? Negative infinity. Still good? All right, last one of these. 2 times 0.4 to the x. So what this one have? Growth or decay? Decay. Always increasing or decreasing? Decreasing. Concave up or concave down? Up as it goes to negative infinity. Positive infinity. As it goes to positive infinity? 0. Good job. Questions? Okay. Last slide we talked about a little bit already, but this plus k at the end causes a vertical shift, okay? And if the output values of g are proportional over equal input values, equal length input value intervals, then f is exponential. So what this basically says, if the output of my transformed function, so the one that is shifted up or shifted down, okay? If the output of that is proportional, that means the initial one had to have been exponential because all I did was take it and shift it up or down. Does that make sense? Okay. And if we look at our input, like if it was -1, 0, and 1, and our graph was, well, I'm going to give something easy, 3, and then 9, and then 27, if the output values are proportional, then the input, or then the original function had to have been exponential. Okay. So that carries through to a transformation that is just shifted up or down. If the initial, if the shifted up or down is exponential, then so is the parent function. Not necessarily the other way around. We good? Okay, so